Okay, let's look at those two examples that are on the box. So log base 3 of x equal to 4. So just like in the when we're solving exponential functions, we want to pay attention to the base. This is the base here, right? So we're going to use the exponential function with that base. So it's going to look like this. It's going to be 3 is the base, 2 the log base 3 of x is equal to 3 to the 4th power. So we treat this whole thing as an exponent and this whole thing as an exponent. Now, using our rules of inverses, right? 3 to the log base 3, those guys undo each other and I just get x back. And so x is just equal to 3 to the 4th, which is 81. So that's it. Simple as that. Now, in the other question, other example question, you had log base 2 of x minus log base 2 of 4 is equal to 8. Okay, actually, this is maybe not the best example because I could have just changed this to 2, right? And that would have been a legitimate way of solving it as well. Let's say though I didn't see this was 2. Or let's say, in fact, this was something more complicated, like let's say this is 5. Okay, then in that case, I'm kind of stuck, right? I don't want to write out the approximation for this as I'm working. So what I'd rather do is I'd rather just combine to a single log. Let's use blue for that. Using my rules of logs, this is log base 2 of x over 5. Right? Take subtraction between logs and it writes it as a division. So now I can do the same thing as before. I'm going to write it like this. I'm going to write it as 2 to this power is equal to 2 to the 8th power. So this is the exponent. That's the exponent. And remember the 2's undo each other here. So this is just going to be x over 5 is equal to 2 to the 8th. What's 2 to the 8th? Let's see, 2, 4, 8, 16, 32, 64, 128, 256. That's 256. Okay, and then just divide both sides by 5. So then x is equal to, or sorry, multiply by 5. 256 times 5. Which is 1,280. So x is 1,280. So that would be how you'd solve that equation. That's all the tools, basically. Let's try the rest of the questions now. We have 6, 7, 8. No, we have 4 more questions. So let's start with number 6. Go ahead and start number 6 if you have not done so yet. So we start off with the easy one. I think I almost did this question. Wait, I did do this question, yeah? I just wrote the same thing as the example?
Yeah, it's the same question.
Okay, so let me just write it one more time real fast. This is 3, that's right. 3 to that is equal to 3 to that, and so x is equal to 3 to the 4. It's 81. Okay. That's that one. Let's go to the next one. Oh, wait. Oh, it said to give an answer and an approximate answer. Oh, I did that though. I did that. Yeah, because 81 is the exact answer. And there's no need to approximate actually because that's a whole number. Maybe the next one will have to approximate. Okay, number 7. Log base 3 of 2x plus 1 plus log base 3 of 4x minus 1 is equal to 2. All right, so here's an instance where I need to combine using my laws of logs before I get started. So I have a plus in between. Remember the rules of logs say I can change plus to multiplication if I pull it into the same log function. So that's going to give me log base 3 of 2x plus 1 times 4x minus 1. This is log of that whole thing equal to 2. All right, the next step is to treat this whole thing as an exponent. So this is 3 to that power is equal to 3 to the second power. The 3 here is going to undo this 3. So I'm just going to get here 2x plus 1 times 4x minus 1 is equal to 3 to the second power, which is 9. All right, at this stage, we actually have a quadratic to solve. Here, this guy is going to multiply out to an x squared term, something with an x squared. And then I just have a whole number, right? So we got to kind of remember back to the old chapters. How do we solve this? We got to FOIL first. 2x times 4x is 8x squared. 2x times negative 1 is negative 2x. 4x times 1 is plus 4x. And 1 times negative 1 is negative 1. Equals to 9, but I don't want the 9 there. I want to have a 0 on one side, right? So I got to subtract 9 on both sides. Excuse me, 8x squared minus 2x. Oh, actually, let's combine these two while we're at it. So negative 2x and positive 4x is a positive 2x. Negative 1 minus 9 is going to be negative 10 equal to 0. All right, so this is the quadratic now that I'm going to have to work on. I'm going to rewrite that on the top left and just work from there. So 8x squared plus 2x minus 10 equals to 0. First thing I notice is I can simplify this by dividing both sides by 2 because everything's even. So it's going to be 4x squared plus x minus 5 is equal to 0. And then at this point, I can just, I could just, let's see, use a quadratic equation. But before I do that, let me just check if there's not a way that it factors nicely. Maybe it'll factor nicely. Let's see, I got a negative 5. Think a little bit. It looks to me like maybe if I put a 4x and an x and a 5 on the one side and a 1 on the other side, maybe that'll work. I want it to be positive, so let's try this. This will be 4x squared. This will be negative 4x. This will be positive 5x, which gives me an x. And then 5 times negative 1 is negative 5. Okay, so it actually factors. I don't have to bother using the quadratic equation. Factors like that, right? That's equal to 0. Equal to 0. And so since it factors nicely, I can just solve those individual pieces. This one is x is equal to negative 5/4. And here x is equal to positive 1. There's two answers. Yeah. There it is. Just as a quick check, let's do one. This is easy. Let's pick x equal to 1 and just see that it works. Are you guys okay with this so far? Can I erase some of the work here?
Yeah.
Okay, I'm going to erase this work here. And what I want to do is just kind of like, that seems like such a weird thing, right? So let me just check that at least one of those solutions is true. Let's plug in x equal to 1 here and see if it works out. So I'll plug x equal to 1. By the way, this is extra. I'm not asking you to do this, but I'm just kind of curious to see how it pops out. So this is log base 3 of 2 times 1 is 1, that's 2, plus 1 is 3. So log base 3 of 3. So log base 3 of, if I plug in 1, that's going to be 4 minus 1, which is 3. So log base 3 of 3. Well, log base 3 of 3 is just 1, right? And log base 3 of 3 again is just 1. So 1 plus 1 is equal to 2 is all it's saying, which is true, yeah. So x equal to 1 is in fact the solution. And I'm guessing something similar will happen with negative 5/4. Maybe not quite as pretty, but in the end it should add to 2. Okay. Oh, wait a minute. You know what, guys? I think we should actually take this extra step. This is actually a necessary step, I think. So one we see is a good solution, right? Actually, I think we need to check. We should check our solutions now that I think about it. Let's check what happens if I put in x equal to negative 5/4. I foresee a potential problem here. We have maybe a false alarm as a solution. So I plug in negative 5/4. I'm going to get log base 3. See, negative 5/4 times 2 is equal to negative 5/2, right? And then negative 5/2. So this is going to be log base 2, negative 5/2 plus 1 plus log base 3 of negative 5/4 times 4 is going to be negative 5. Right? Okay, here's the problem. I have log base 3 of negative 5/2 plus 2/2 is negative 3/2. And this is log base 3 of negative 6. But this is not true because I cannot take a log of a negative value. It's actually log function is undefined for negative values. Same for here. So this is actually not a solution. It's not true, which means this was actually not a solution. It's a false alarm solution. Does that make sense to you guys?
So each time we have two different answers, we should check both of them.
You should check them, yeah. You should check them.
But if we only have one answer, do we need to check?
So if the equation is linear, you don't need to check.
All right.
But if you have something that comes out to like a quadratic where you solve it, then yeah, you should check because you gotta just look out if you have a negative. If one of your answers will pop out negative. Or 0. You also can't take logs of zeros. So if one of them happens to be 0. So yeah. Trying to think if there is. If it's just a single log function, I don't think you ever have that issue. But when you have like these more complex ones, then yeah, you get stuff like that. Okay, let's finish up the last two. Okay, number 8. We got log of negative 4x plus 17 plus log of x plus 6 equals 2. Okay, so similar type of question it looks like. First thing is to combine the logs. So it's going to be log. Oh, this is just a regular log. Yeah, it doesn't say base anything. So that means it's log really base 10. So log base 10 of negative 4x plus 17 times x plus 6 is equal to 2. All right, then we're going to take 10 to both of these as exponents. This is 10 to the, this is really a hidden 10 here. So that's going to pop this whole thing out. Negative 4x plus 17 times x plus 6. Equal to 10 squared is 100. All right. Okay, it's looking a little bit ugly, but that's okay. Let's just multiply the thing out then. We're going to approach it the same exact way. Negative 4x times x is negative 4x squared. And negative 4x times 6 is negative 24x. 17 times x is plus 17x. And then 17 times 6, that is equal to 102. So plus 102 equal to 100. All right, I want to do the same thing as before, move all the numbers to one side. It's going to have 0 on the other side, so it's going to be negative 4x squared. Let's combine these two guys. Let's see, that's negative 7x. And then subtract 100 on both sides. That's going to be plus 2 is equal to 0. Now, you know, when you're trying to factor this thing, I'm going to try to see if it will factor possibly. And let's see, is it going to factor? I don't think it is. I'm trying to think about this. Negative 2. Yeah, no, I don't think it's going to factor. Okay, but in any case, I don't really like to work with this negative in the front. So what I like to do is just divide both sides by -1. If I divide 0 by -1, it doesn't change. But I can flip all these signs if I divide by -1. So it's going to be 4x squared plus 7x minus 2 is equal to 0. That's the quadratic I'm going to work with. Let me do that on the left just like the last time. I'm going to come around to this side. Start by copying down that equation. 4x squared plus 7x minus 2 is equal to 0. And this time, I think I'll just skip straight to the quadratic equation because I don't see a nice way that this is going to factor looking at it. So let's use a quadratic equation. X is equal to negative 7 plus or minus square root of 7 squared minus 4a, which is 4, c, which is negative 2. All over 2a, which is 2 times 4. All right, this part is just kind of routine, right? Negative 7 plus or minus the square root of, this is 49. This is negative. Let's see if you can see, this is a 4 here. So 4 times 4 is 16 times 2 is 32. So it's 32, but negative times negative is actually a positive. So 49 plus 32 gives me 81 on the top. This is 81. Oh, I think actually it might have factored. I just didn't see it. All over 2 times 4 is 8. Yeah. Okay, so then let's continue on. This is negative 7. Square root of 81 is just 9. So negative 7 plus or minus 9 over 8. And let's do the positive first. Negative 7 plus 9 is positive 2 divided by 8 is 1/4. Negative 7 minus 9 is negative 16 divided by 8 is negative 2. Okay, so actually it did factor. I just didn't see it. So if you factor this instead, then that would have worked. Anyways, I have 1/4 or negative 2. These are my potential answers, right? But I need to come back now, just like before, and just make sure that I don't have a negative or a 0 if I plug those in. Okay, so last step, I'm going to come back to the beginning. I'm going to look at my function. See what happens if I plug in 1/4 and if I plug in negative 2. I'm actually not going to plug to work out all the details. I'm just going to take a look if it's positive or negative. So I'm going to do 1/4 first. I do 1/4 here. This is going to become a -1 plus 17 is positive. So that's okay. If I put in 1/4 here, positive plus positive is still positive. So it's positive. So that's okay. So 1/4 is an answer for sure. That's good. Okay, what about negative 2? If I plug in negative 2 times negative 4 is actually positive 8. Negative 2 plus 6 is positive 4. So that one's okay too. So actually, these are both solutions this time. Okay, does that make sense to you guys?
So when you're checking the answers, does it just matter if they're positive or if they actually equal the number on the other side?
They should equal the number on the other side. But
Okay.
the only issue I really see is if you have a log of a negative or a 0, then it's undefined.
Okay.
Yeah, I'll just show you real quick. Let's just check. So this, if I plug in 1/4, this would be -1 plus 17. So that's log of 16 plus log of negative 1/4, I'm sorry, 1/4, it'll be 6.25, right? Okay, so let's see if this is true. Log of 16 plus log of 6.25. And that's indeed equal to 2, see?
Okay.
Let's check the other one, make sure. So log base, if I plug in a negative 2, it's going to be 8 plus 17 plus log of 4 is equal to 2. And 8 plus 17 is 25 plus log of 4. So let's see, log of 25 plus log of 4, and also equal to 2. See?
Okay.
Okay. See, my computer is dying, so I'm gonna grab my charger real quick. I'll be right back in a second. Down to 1%. All right, guys, we're gonna do the last question now. So I'm gonna erase all this. Okay, we're number 9 now. This is solve log base 5 of x plus 5 minus log base 5 of x squared plus 25 equals to -1. Okay, so just like before, same first step, I want to just combine to a single log. I got a minus in between this time, which means it's going to look like log base 5 of the top one divided by the bottom one. Divided by the one that's subtracted. Equals to -1. And this time log base 5, so I'm going to take 5 to that power. It's equal to 5 to that power. Yeah. And the 5's undo each other, so this is going to be just on the left side, whatever is inside. So it's going to be x plus 5 over x squared plus 25. And on this side, 5 to the -1 power is 1 over 5. Okay, so that's the equation I need to solve now. To solve something like this, I don't really need these parentheses anymore. I can just cross multiply, right? Or you can think of it really as doing 2 steps, multiplying both sides by 5 to get rid of this 5, and then multiplying both sides by this denominator x squared plus 25. When I multiply by x squared plus 25 on this side, it just cancels. So it just pops out on the right side, right? What I'm trying to say is that you're going to end up with 5 times x plus 5 on the left. On the right, you're going to end up with 1 times x squared plus 25. So that's what I'm trying to solve here. So next step, let's just simplify this thing. This is going to give me 5x plus 25 is equal to x squared plus 25. Oh, that's nice because the 25s are going to cancel each other out, right? And then I can just subtract 5x on both sides. So I'm going to have x squared plus 5x is equal to 0. Oh, I'm sorry. That should be minus 5x. Yeah. Subtract 5x on both sides. X squared minus 5x is equal to 0. Alrighty, let's take this guy and just work with him on the left side over here. So I'm going to recopy down what I had. 0 is equal to x squared minus 5x, but this is easy to factor. Let's factor out an x minus 5. So I've got two potential solutions, x equal to 0 or x equal to 5. Let's see. These are my possible solutions. Just like before, I'm going to come back to my original and just make sure I have no issues. Okay, and I don't see anything, I don't see any issues happening because if I plug in 0, this is going to be positive 5 inside. If I plug in 0, it's positive 25. If I plug in 5, it's going to be 10. Plug in 5, it's going to be 50. So it looks fine to me. Both of these are solutions. Just to be absolutely sure, let's just see what those numbers come out to be. So this would be, if I plug in 0, it's going to be log base 5 of 5 minus log base 5 of 25. Log base 5 of 5 is equal to 1. Log base 5 of 25 is equal to 2. So 1 minus 2 is equal to negative 1, and that checks out. If I plug in 5 on the other hand, I get log base 5 of 10 minus log base 5 of 5 squared is 25 plus 25 is 50. So let's see if log base 510 minus log base 5 is 50. Actually, in order to plug this into the calculator, I want to combine to a single log. So let's do this log base 5 of 10 divided by 50, which is log base 5 of 1/5. Oh, actually, I can see already here. 5 to the negative 1 is equal to 1/5, so negative 1. And that does check out as well. So indeed, both of these were solutions. This is a check mark here. It's supposed to be. Check. All right, guys, that's it. Well done.